So this is the most misunderstood item in Dota 2, the weighted dice. Now weighted dice was added in the recent patch where there were a ton of other changes, but this is really the most confusing item out there, right? It's only a tier 1, but somehow it confuses so many people, and there have been debate after debate about it online. Yeah, it's just a really confusing item if you don't know how Dota works. So basically what the weighted dice does is it gives you a passive which really when you are hitting base damage or creep bounties, right, the value is computed twice and the highest damage is taken. Now this makes no sense if you don't know how base damage or creep bounty works, right? So I went to test this out in an actual match, but before that we will try to do it without this neutral item with some other neutral item. So really if we go to any target like this and start hitting, all heroes have a damage spread, right? So really different heroes have different damage spread. Some are bigger than others, but damage is not fixed, right? So you will never do a fixed 60 damage, right? One hit you could do 60, while another hit you could do more, right? So this hit I did 79, then I did 74, then I'm doing 76, right? So I didn't change anything, my level still 4, and somehow on each hit I'm doing a different damage value, right? So now these damage values are random and we can see what happens if I start equipping my neutral item, the weighted dice, right? So you can see that generally I'm hitting on the higher end right now. We got lucky with that, but you can see there's more 79s now, right? So this does increase your damage. So it works the same way with creeps. If we walk over with the new hero Lago to the creeps, you can see the before and after effects. So let me take this out, let's equip something else, maybe I equip this and just watch the bounty. I'll hit 2 creeps and 1 melee. So you can see this creep gives me 38, so that gives me 39, right? This gives me 34, so you can see the creep value is actually not standard, right? This gives me 38, so it's actually not fixed at all. So if we upgrade this and change it to the weighted dice, it should give us a higher general value, right? So to really understand how this item works, we have to understand how probability works in mathematics. So now's a good time to pray you had listened in those math classes, which I assume you were playing Dota instead of actually listening in math classes, right? So you can see I'm getting higher values from hitting the last hits, right? Okay, great. Now it's time for math lessons. So I'm going to use the example of a hero with 65 to 70 damage, right? Now to make things simpler, this is equivalent to having the hero have a damage of 64 damage plus whatever I roll on the dice, right? Because if I roll a 1, it's 64 plus 1, which gives me 65. If I roll a 6, it's 64 plus 6, which gives me 70, right? So I can get a range of 65 to 70 damage by thinking of 64 plus whatever I roll on the dice, and that's really how Dota works as well. So to get the average damage of this hero per se, it's really simple. So since there are 6 sides on the dice, each side has a 1 in 6 chance of happening, right? So to calculate the expected value when I roll a dice, right, it's basically the average value if I roll the dice. A lot of times I need to take the chance of each side happening times the value of that chance and sum everything up. So the chance of rolling a 1 is 1 over 6, right? So I will take 1 times 1 over 6. The chance of rolling a 2 is also 1 over 6. So I will do 2 times 1 over 6 and continue on 3 times 1 over 6, 4 times 1 over 6, and so on and so forth. And it will give me this equation, right? Which will give me about 3.5. So when I roll a dice, the average value I'm rolling each time is a 3.5. So if I add that to 64, the hero will do 67.5 damage on average if their damage ranges from 65 to 70. Now this is quite simple. I hope you are still following. The problem gets a bit more complicated when I roll it twice and take the max. Okay, so with a bit of cheating on my math homework with ChatGPT, here it is. So basically, let's imagine M is equal to the max of 2 dice rolls. So this is really what the new item does. It really takes a maximum of 2 dice rolls, right? So that's M. So that's what we want to find. We want to find what the expected value of M is, right? So how do we find the expected value of 2 dice roll, the maximum of 2 dice roll, right? So the chance of M being less than or equal to k, which is the chance of the maximum of two dice rolls being less than or equal to k, where k is 1 to 6, right? Is actually the chance of the first dice roll being less than or equal to k times the chance of the second dice roll being less than or equal to k, right? So if k is 4, what's the chance of one dice roll being less than or equal to 4? 4 over 6, right? It's very simple. What about two dice, both dice being smaller than or equal to 4? It's a bit more tricky, but it's really just 4 over 6 times 4 over 6, right? So you multiply the chance of each dice happening together, so it's 4 over 6 square, right? So this works whether k is 1, 2, 3, 4, 5, 6, right? If k is 2, then it's 2 over 6 and 2 over 6. So you can get the probability of m less than or equal to k is equal to k over 6 square, right? Now we can actually solve. So what's the probability that the maximum of two dice rolls is equal to k? So what's the probability of two dice rolls, the maximum being 4, right? We can look at this equation that the probability of two dice rolls being exactly 4, the maximum of two dice rolls being exactly 4 is the probability of both dice rolls, right, being 4 or less, minus the probability of the maximum of both dice rolls being 3 or less, right? Because if you think about it, if the maximum of both dice rolls is 3 or less, right, it can no longer be 3, 2, or 1, right? Because 3 or less includes 3, 2, 1. So if you take the maximum is 4 minus 3, right? 4, because 4, you can have 4, 3, 2, 1, right? But you minus 3, 2, 1, you are just left with 4. So you get this really nice equation where the probability of the maximum of two dice rolls is equal to uh, m less than or equal to k minus m less than or equal to k minus 1, right? So it's really k over 6 square minus k minus 1 over 6 squared. So how do I get the second part is really, I mean, if k is smaller by 1, it still fits the same equation, right? So with this, we are actually done. We know how to get the chance of each occurrence happening. So as I mentioned earlier, the expected value is the occurrence chance times the occurrence value, right? So let's say I'm looking at number 2, this will be 2 times 2 over 6 square minus 2 minus 1 over 6 square. Right now, I do this for 1, 2, 3, 4, 5, 6, add it all together, and I get about 4.47 in this case, right? So yeah, that's math for you. So what this means is if I roll a fair dice twice and take the highest number, my expected value jumps up from 3.5 to 4.47, right? So yeah, that's how this item really increases your damage. Now I'm going by 1.27 damage higher than normal, right? So obviously if your spread is bigger, the jump is higher. And yeah, that's it for the math section of this video. I hope you understand. If you don't, it's fine. I don't think a lot of people will understand this, but yeah, just make sure to like this video. I do plan to make more Dota 2 content in the future, so make sure you subscribe as well and leave a comment on whether you understand the math and if my math was correct. Yes. And of course, please comment if you are buying this item. Thank you and goodbye.